Let's move on to control systems. Complicated AV kills meetings. Control systems exist to hide complexity, not celebrate it. Don't be that guy. The goal of a control system is invisibility. It lets the user focus on communication, not buttons. A good control equals cognitive silence. One touch, one result. When users fight the interface, the design failed. Simplicity is the highest form of control. User experience is the most overlooked aspect of AV design by far. Recall that AV rooms are filled with mismatched devices. Displays, switchers, DSPs, lighting. A control system is unifying disparate equipment. A control system links them through logic and protocol. The process translates human intent into machine action. Think of it as the systems interpreter, taking start meeting and converting it into 10 separate commands in sequence or in parallel. One processor, many dialects, one fluent response. And when you define control requirements as you spec a system, begin with 2 columns. Left is every controllable device, and right, what each must do. For example, display, power, input select, volume, DSP, preset recall, mute, lighting, scene control. This becomes your control function matrix, the programmer's Bible, if you will. So define clearly before you design, and design for functionality. So what gets controlled? And remember interoperability, how those devices talk, serial, IP, IR, and of course, interconnectivity, where they are physically and logically linked. Every system must define all 3. Clarity at these layers prevent chaos in programming. Let's talk about logic flow. When a user presses a button, the path is linear. Input to processor, a processor pushes a command output, and then the device feeds back to the processor, which is then displayed to the user. So latency, missequencing, or feedback delay all break trust to the user. Map control flow like signal flow. Step by step. Map logic as precisely as you map audio and video. There are a few control protocols that you're going to encounter in the field. Different gear speaks different control languages. RS-232 or 422 for legacy serial control. Infrared for consumer gear like remote controls or others. TCP or UDP IP for modern network control. You will of course see CresNet, AMX, QSys, REST API or Dante Managed API. So always choose protocols that return status feedback, not blind commands. Two-way feedback turns control into confidence, and this is a huge part of user experience. And when it comes to user interface design, the user interface must mirror mental models, not a hardware structure. So group sections by user intent. Start, present, call, record, end. Avoid device-centric labels like HDMI 2. Use behavior labels like laptop input, for example. Users think in actions, not inputs. Remember that. And when you're designing control systems, remember that modern control processors are software-defined. So test logic before deployment. Simulate button presses, verify device responses, and confirm feedback loops. Code defensively. Handle missing devices, timeouts, retries. Predict failure, because it will happen, and code against it. And don't think that the control system exists in isolation. Control no longer stops at AV. Lighting, HVAC, blinds, occupancy sensors, all expect integration. Each uses its own protocol. BACnet, Modbus, KNX. Your control system becomes the handshake point. The modern AV designer must think like a system integrator. Need to understand all these protocols and how to integrate them together. And design for failover and redundancy. Every automated environment eventually fails, so plan backup modes, local power switches, manual overrides, redundant controllers. Design so that one failed processor doesn't end an event. Reliability is a design choice, not luck. Control design is the art of hiding complexity. Define every function, map every command path, and test logic as rigorously as audio and video. Because when control works right, the user never notices it. Elegant control disappears in use but never fails under pressure.